Welcome to Astronomy Daily, your source for the biggest news from across the cosmos. I'm Anna.
And I'm Avery. It's great to be with you. Today we've got 5 incredible stories that span from our own cosmic backyard to the very foundations of the universe.
That's right. We'll be looking at a shocking discovery that our solar system is moving much faster than it should be. Then we'll cover a major rebrand for Amazon's satellite network and some high-stakes drama unfolding aboard China's Tiangong space station.
Plus, Europe is getting a sleek new spacesuit, and we'll dive into a mind-boggling new simulation that has recreated our entire Milky Way galaxy star by star.
It's a packed show. Let's get started. Avery, let's begin with a story that genuinely challenges our fundamental understanding of the universe. A new study has found that our solar system is hurtling through space far faster than our best cosmological models predict.
Wait, faster than we thought? By how much? We already know we're moving pretty fast, orbiting the galaxy at hundreds of kilometers per second.
Significantly faster. The evidence is fascinating. It comes from observing the distribution of radio galaxies across the sky. According to the standard model of cosmology, the cosmological principle, the universe should be isotropic, meaning it looks the same in every direction on a large enough scale.
Right, no specific direction or location. The ultimate cosmic democracy.
Exactly. But when astronomers mapped out these distant radio galaxies, they found a lopsided distribution. There are more of them, and they appear brighter in the direction our solar system is moving. This is a classic Doppler effect, similar to how a siren sounds higher pitched as it moves towards you. The light from these galaxies is being blue shifted.
So because they look brighter in one direction, it implies we're rushing towards them much faster than we accounted for.
Exactly. And here's the kicker. The statistical significance of this finding is 5 sigma.
5 sigma? For our listeners, that's the gold standard in physics. It means there's only a 1 in 3.5 million chance the result is just a random fluke.
It means this is very likely a real physical effect. This doesn't just mean our maps are a little off. It could mean the cosmological principle itself, this idea that the universe is uniform, might have flaws.
That is a massive implication. It's like finding out the whole ocean has a current you never knew existed. Truly a foundational shakeup.
That's putting it mildly.
All right, from the cosmic scale back down to low Earth orbit, our next story is about a big shift in the satellite internet race. Anna, you've probably heard of Amazon's ambitious plan, Project Kuiper.
Of course, their answer to SpaceX's Starlink. The goal was to provide affordable broadband internet to underserved communities around the globe. A very noble and very challenging goal.
Well, it seems the branding and perhaps the focus is changing. Amazon has officially rebranded the network. It's no longer Project Kuiper. It's simply now LEO.
LEO, as in low Earth orbit. That's certainly more direct. Does this name change come with a strategy change?
It appears so. The marketing language is shifting away from that initial pitch of connecting individual homes in remote areas. The new emphasis is squarely on larger commercial and enterprise contracts. Think telecommunications companies, governments, and large corporations that need reliable, high-speed data connections for their operations.
That makes sense from a business perspective. Those enterprise contracts are where the big, reliable money is. It also puts them in more direct competition with the higher-tier services offered by Starlink, which has also found a lucrative market with aviation, shipping, and enterprise clients.
Exactly. So while the name LEO is new, the real story here is the strategic pivot. It's less about internet for everyone and more about becoming a dominant player in the high-stakes commercial satellite data market.
Now, for some developing news that sounds like it's straight out of a movie script, there's some serious drama unfolding aboard China's Tiangong space station.
Oh, this sounds intense. What's happening?
Well, the most recent crew to return to Earth, the Shenzhou 20 crew, had to come home in a replacement spacecraft. Their original ship, which was docked at the station, was damaged by a small piece of orbital debris.
Whoa, okay, so a replacement ship, the Shenzhou 21, had to be sent up to bring them home. That's a good contingency plan.
It is, but it's created a very serious secondary problem. The replacement ship, Shenzhou 21, was also carrying the new crew for the station. So it went up with the new crew, docked, the old crew got in, and it returned to Earth.
Okay, I think I see where this is going. The new crew is now on the Tiangong station, but their ride home just left.
Exactly. For the first time, the crew on Tiangong is without a lifeboat vehicle. Every docked spacecraft, like a Soyuz at the ISS or a Shenzhou at Tiangong, serves as an emergency escape pod. If there were a major fire, depressurization, or a medical emergency, they have no way to evacuate.
That is a terrifying situation. What is China doing about it?
They are moving fast. The next spacecraft, Shenzhou 22, is being prepared ahead of schedule to be launched as soon as possible. But there's another complication. The damaged Shenzhou 20 spacecraft is still docked to the station, taking up a valuable port. They have to figure out how to safely undock and deorbit that damaged ship to make room for the new one. It's a tense and complex orbital chess game with human lives at stake.
Well, on a lighter note, let's talk about space fashion, or more accurately, spacewear. The European Space Agency is getting a brand new European-designed spacesuit.
This is exciting. For a long time, astronauts on the ISS have mostly used either American or Russian suits. Is this a suit for spacewalks?
Not this one. This is an IVA suit, which stands for Intravehicular Activity. It's the suit you wear inside the spacecraft during launch, docking, and re-entry, the high-risk phases of a mission. It's your last line of defense if the cabin loses pressure.
Ah, the so-called pumpkin suits. They're crucial pieces of safety equipment. What's special about this new European one?
The big design feature they're promoting is speed and ease of use. It's designed to be put on or taken off by a single person in under 2 minutes without any assistance. In an emergency, every second counts, so that's a huge deal. French astronaut Sophie Adenot is scheduled to be the first to test it on the ISS in 2026.
That's fantastic. And this is more than just a new piece of hardware, isn't it? It's part of a larger strategic goal for Europe.
It is. The ESA has explicitly stated that this is a step towards achieving sovereignty in human space exploration. By developing their own critical technologies like spacesuits and eventually their own crew vehicles, they reduce their reliance on partners like NASA and Roscosmos. It's about securing Europe's independent access to space.
And finally, Avery, we have a story that is simply staggering in its scale. Scientists have successfully created the first ever simulation of our entire Milky Way galaxy that tracks the evolution of over 100 billion individual stars.
100 billion with a B? I can't even comprehend that number. How is that computationally possible? Previous simulations could only handle a tiny fraction of that.
That's been the exact problem. The huge hurdle was modeling supernovae. These are incredibly important for galactic evolution. They spread heavy elements and energy, but they are also extremely fast and chaotic events. Simulating their blast waves and chemical reactions in detail requires immense computational power. A single supernova could grind an entire galactic simulation to a crawl.
Right, it's a scaling issue. The physics at the micro level of the explosion tanks the macro level simulation of the galaxy. So what was the breakthrough?
Artificial intelligence. A team of scientists developed an AI deep learning model. They trained it on countless high-resolution simulations of individual supernovae. The AI learned the patterns and outcomes so well that it can now instantly predict the effects of a supernova without having to run the full, slow simulation each time.
Wow, so they essentially outsourced the hardest part of the calculation to a predictive AI. That's brilliant. What kind of machine did they run this on?
They used one of the most powerful machines on the planet, the Fugaku supercomputer in Japan. By combining this clever AI shortcut with Fugaku's raw power, they were able to simulate the whole galaxy. This is going to revolutionize how we study everything from star formation to the distribution of dark matter. We can now watch a digital version of our galaxy evolve over billions of years and compare it directly to what we see in the sky today.
It's like having a galactic time machine, an absolutely monumental achievement. And that's all the time we have for today. What a journey. We learned that our solar system is a cosmic speedster, challenging the very principle of a uniform universe.
We saw Amazon's Project Cooper rebrand to LEO with a new enterprise focus. And we're watching a tense situation at the Tiangong station as China rushes to send up a lifeboat for its crew.
Plus, Europe is gaining independence with a new quick-change spacesuit, and scientists have used AI and a supercomputer to build a stunningly complete simulation of our Milky Way.
Thank you for joining us. From all of us here at Astronomy Daily, keep looking up.
Astronomy.